Okay, welcome you all. In this session, we'll discuss about entropy change in different process. Okay, so we'll discuss about entropy change in different process, right? Okay. The first process, we know that, we have explained. Let us look at this first process. This process is isobaric process. Well, in isobaric process, we know that the pressure remains constant. This implies in this condition, this pressure is constant. Okay. So on PV plot, we have already seen these are the constant pressure process. Okay, this x-axis and y-axis. Right. Let us try to explain this process on TS plot. Okay. On TS plot, this is constant pressure process. This curve will be like that. Okay. This curve will be like that. Okay. Right. We have already explained in work. Let us suppose this is the two process 1 and 2. Okay. This is process 1 and this is 2. The process 1 is explained on this PV plot, and the same process is explained on this TS plot, right? And you know that, as we have explained in brief in work, in this process, this heat is added. This heat is added. Why? You know that. This is the guiding equation P is equal to mRT. In this process, the pressure is constant, M is constant, R is constant. That means volume rate is constant to temperature. This implies if heat is added, in this condition, what will happen? The temperature will increase. If temperature increases, that means volume will increase, right? And in this process 1, since volume is increasing, because we are moving from left to right, in this condition, what we will observe here, this volume is increasing. That's why the process 1 is heat addition process. Similarly, in process 2, this heat is rejected. Okay, this is already explained in work. In the same way, on TS plot, on x-axis the entropy is there, and the y-axis this temperature is there. When heat is added, temperature increases, and we know this in the equation 1. This is in curve 1. In this way, when the direction will be upward, in this condition, what will there? The temperature is increasing in this condition. That means in process 1, heat is added. That in this process 1, this heat is added. And in next process, since temperature drops, that means heat is rejected. So simple, on TS plot, since process is isobaric, that means this pressure is constant, mass is constant, gas constant, already constant. That means volume rate is constant to temperature. whenever heat is added, in this condition temperature increases. If heat is added, the temperature will increase. And on TS plot, this in plot 1, in this condition what we will observe? Since direction is in upward direction, that's why this temperature increases. That's why this curve 1 represents heat addition and curve 2 represents heat rejection. So this curve 1 represents heat addition and curve 2 represents heat rejection, right? Similarly, on this PV plot, this curve 1 represents heat addition and curve 2 represents heat rejection. Okay, so there should not be any confusion while drawing any process either on PV plot or TS plot. There should not be any confusion. Okay, that's why I am dealing every process one by one. Okay. Now the process, the question begins here. For isobaric process, how much the entropy change will be? Let us suppose this is process 1. This is initial 1 and 2. See that 2 point. This initial point is 1 and final point is 2. Okay. So we have to change. Let us draw this one once again here. TS plot. This is process. This is 1 and 2. Okay. Undoubtedly, in this process, this heat is added. Okay. Heat addition takes place in this process 1 to 2. Okay. Right. Now we have to find the change in entropy in process 1 to 2. Okay. We have to find the change in entropy for process 1 to 2. Okay. So in this condition, what will you observe here? Just right. We have already two equations. This one equation TdS is equal to du plus PdV, and next TdS is equal to dH minus BdP. Okay. In this process, since pressure is constant, that's why you pick this equation. Why? Because in this condition, this dP is there. In this condition, this dP is there. Therefore, let's pick this equation. That means TdS is equal to dH minus VdP. Since pressure is constant, this implies dP will be 0. So, in this condition, the TdS is equal to dH, this dH is equal to Cp dt. So, this dS is equal to Cp dt by t. We have to integrate this one. Okay. Simply we have to integrate this one from when entropy is S1, entropy is S1, temperature is T1, and when entropy becomes S2, temperature becomes T2, right? So in this condition, this temperature will be T1 to T2. So this will be equal to del S is equal to Cp ln T2 by T1. This is the change in entropy for isobaric process, right? So remember this equation. This equation is important. This equation is important only for isobaric process. This expression is very simple. We have to pick. These are two parenting equations. Okay, we have to pick one equation as per given condition. Since pressure is constant, that's why I'm picking this equation, because the pressure constant, that means this term will be 0. Just use this equation, just put this dp is 0, you will get this one. Simply you have to integrate this del S is equal to Cp Ln T2 by T1. The change in entropy in this constant pressure process, that is process 1 to 2, this is equal to Cp Ln T2 by T1. Right? Right. Now, let us suppose the next process says isobaric, sorry. Next process is, let us suppose isobaric process. Okay. In this process, we know that this volume is constant. We already know this one. And on PV plot, there will be two curves, let us say this 1 and 2. Okay. In process 1, what will happening? In process 1, this heat is added. How? Because we know this PV is equal to MRT, this is parent equation. Volume is constant, mass is constant, and gas constant already constant. So, in this condition, what we observe here, this volume constant, mass constant, this one. This implies pressure directly constant to temperature. As in this case, as we follow this curve 1, if heat added, that means this temperature will increase. When temperature increase, that means since temperature is proportional to pressure, in this condition this pressure will increase. So in this condition, in process 1, the pressure increases. That's why in this process, this heat is added. And it is just vice versa. In this condition, heat is rejected. Okay. Now, just explain this process on TS plot. This is constant volume process 1 to, let us say this is process 1 to 2. In process 1 to 2, just we have to find whether heat is added or rejected. Suppose that this is process 1, and let us suppose this is another process. Okay, this is process 2. Okay, we have to identify in which process heat is added and in which process heat is rejected. Okay, simple. Already we have known when heat is added, the temperature increases, and you know that when you follow the curve 1, what you will observe here, in this condition, this temperature increases. That's why in this process heat is added. In this condition, this temperature drops. That's why this heat is rejected. Okay. So whenever we have to draw the isobaric process on TS plot, simply we have to follow this concept. This is simple guiding equation. With the help of this guiding equation, we can plot the situation either on PV plot or TS plot. This is very simple. Okay. Now we have to find the change in entropy in this process. Okay. So already we have two equations. Okay. TDS is equal to du plus PdV, and next TdS is equal to dH minus ddP. Since volume is constant, that's why peak distribution. Okay, because this dB is there, therefore TdS is equal to du plus PdV. Volume is constant, that means this implies dB is 0. So the TdS is equal to what is du? Du Cv dt. So ds is equal to Cv dt by t. Simply we have to integrate when entropy is S1. Let us suppose this for this process. When entropy is S1, the temperature is T1. Temperature T1. When entropy is S2, temperature is T2. This is equal to del S is equal to Cv ln T2 by T1, right? Cv ln T2 by T1. So this expression is only valid for which process? This is valid for isoporic process. So what is basic difference? Change in entropy for constant pressure process. This is del S is equal to Cp ln T2 by T1 for constant pressure process, and for constant volume process this will be Cv ln T2 by T1, right? Okay. We'll meet in next slide.